Okay, so we are going to discuss today the inert gas system. In this video, we are going to see the need of inert gas system and what are the various components of inert gas system, what are the SOLAS guidelines, advantage, disadvantage, and the IG blowers, your scrubber towers, different types of deck seals, the PV valve and PV breaker. All these things we are going to see in the detail in this slide. We are going to see about the need of IG gas in tanks. Basically, when we talk about the crude oil tankers or the product tankers, the flammable atmosphere is there inside the tank, and if we can maintain the oxygen percentage less than 11% by volume, then we can prevent the fire and explosion to happen. So this main motto is being achieved by the filling the inert gas inside the tanks. We have the fixed piping arrangement to blow the inert gas into the tanks, and in order to reduce the air content of the oxygen and render the tank atmosphere non-flammable. That is the main purpose of the IG system. The International Convention of Safety of Life, that is your SOLAS, the amendments, the regulations, they require the IG capable of delivering the IG gas into the system at 5% by volume. That is the unrequired rate of flow. That means at the point of generation, the oxygen content inside the IG should be less than 5%. But the tank atmosphere inside the tanks, the oxygen percentage, it should be less than 8. That is the SOLAS guideline. And if we can achieve it, we can prevent the explosive environment. So what happened, as the inertness we are signifying, so we are keeping the oxygen percentage less than 8% inside the tank, and in this atmosphere it is not going to react. Also the reactivity also goes very less. If this inability to react, even if the safe by preventing or unwanted chemical reactions, that is your oxidation is also not possible when we talk about the oxygen percentage less than 8%, and this prevents the corrosion also inside the tank. That is also one of the main advantage. The inert gas is generated on board ships, usually in your oil tankers, either by independent inert gas generator or by conditioning the boiler flue gases. Okay, in this one we are going to see about the composition of the inert gas. And composition, let's say this is the component column, this is your before scrubber, this is your after scrubber. Okay, so all the components, you can see the nitrogen approximately 80% by volume and approximately 80% by volume. So before scrubber, after scrubber, same. Carbon dioxide, before scrubber, after scrubber, same, 14%. Oxygen, same, 2 to 5% by volume, 2 to 5% by volume. Then water vapor, it's approximately 5% by volume and approximately 2% by volume after scrubber. That means the percentage of water content inside the IG will be reduced. Okay, carbon monoxide, that is your CO, approximately 0.01%, 0.01%. Nitrous gases 0.02, 0.02. Sulfur dioxide, there is a drastic change, you can say. That's why the scrubbers are fitted into the ships for the reduction of sulfur content or SOx. 0.3% to 0.005%, a huge reduction. Soot 300 mg 30, that is also the huge reduction happening. In this one we are going to see about the advantages of IG system. Inert gas in cargo tank make the atmosphere non-explosive. It allows the high pressure tank washing and reduces the tank cleaning time also. Okay, allows for cow washing also it is required. Reduce corrosion in the tanks. At oxygen percentage is less, corrosion is being reduced. Improve the stripping efficiency and reduces the discharge time. Aid the safe gas freeing of the tanks. It is economical to operate. It forms the readily available extinguishing agent for the species. Okay, and reduces the loss of cargo through evaporations, and complies with the legislation and reduce the insurance premium. These are the factors which gives the advantages as the IG system is installed on board ship. Okay, we are going to see about the disadvantages of IG. As we have seen already the advantages: additional cost for installation because this is extra thing, and this is just a requirement, that's why it has to be there. Additional maintenance, of course, the manpower is required, the money is required, time is being required because the extra machineries are being installed. Low visibility inside the tanks, of course it is, but with low oxygen content, tank access is also being denied. Could lead to the contamination of high grade products. Okay, if it is white oil or the product, then we have to use the IgG. Okay, moisture and sulfur content corrodes the equipment. This is also part of it. Established reverse route of the cargo to enter the engine room. Okay, and oxygen content must be monitored and alarm sensed all the times. That has to be taken care of all the time, and the oxygen content is the vital form of or vital thing to be monitored in case of the IG system. Pressure as well as oxygen content. Instrumentation failure could lead to the fail-safe device putting at the ship at risk. Okay, of course the operations will be not safe if it is not there. Okay, additional gas generator is required in the case of the system absence of the waste heat product of the boiler flue gases. Okay, so additional IgG is being required if the flue gases are not being utilized. So these are the advantages of SOLAS guidelines. As we are going to see about the SOLAS guideline, or you can say as per the FSS code and the IBC code. Okay, so the fitting of the fixed inert gas system is required for the tankers of 8,000 tons deadweight and over constructed on or after 1st January 2016. Previously, this applied only to the tankers. Previously, it was applied to the tankers of 20,000 tons and deadweight and over. Okay, so now this is 8,000 tankers, 8,000 deadweight and over carrying low flashpoint cargoes and constructed key laid after 1st January 2016 must be provided with a fixed inert gas system. That is your chapter 15 of the FSS code. Okay, in that one it is incorporated. Existing clause in SOLAS chapter 2.2, that is your construction fire, and 4.5.5.2 for waiving the requirements of a fixed inert gas system still applies to all gas carriers. But for chemical tankers, it now only applies to those constructed before 1st January 2016. This means that the chemical tanker constructed on or after 1st January 2016 and carrying flammable cargo such as listed in your IBC code chapter 17 and 18 will be required to have a fixed inert gas system regardless of the cargo tank size and the tank washing machine capacities. So this is also the part of it. Now we are going to see about the operational requirement for the chemical tankers. Earlier we have seen about the SOLAS guidelines for the tankers and chemical tankers also. This chapter 2 to 16.3.3 that clarifies the operational requirement for inert gas system and the sequence of applying the inerting medium into the cargo tanks. How and where it is being applied, it is given in the, or basically you can say the sequence is given in the this regulation 2 to 16.3.3. Regulation 2 to 16.33 allows also the chemical tanker the option to being inerting their cargo tanks after the cargo tank has been loaded. Okay, so after loading also the padding and all is being done, but before commencing unloading, but only if nitrogen is used as the inerting medium. So inerting medium also they are given as a nitrogen. In this instance, the nitrogen inerting should continue until the cargo tank has been purged and freed of all flammable vapors prior to the gas freeing part. That is also true. The changes to the IBC code clarify the operational procedure for new and existing chemical tankers. Okay, so these changes are applied for both, that is your new and existing chemical tankers. Chemical tankers which carry products containing oxygen dependent inhibitors, that is also being required. Regulation for IG blowers. This is also the guidelines that is for the IG blowers. Minimum 2 numbers of the blowers to be fitted in the IG system. The capacity of each blower must be 1.25 times the overall capacity of the cargo discharge system. This is to ensure that the inert gas is always present in the cargo hold. Okay. Only one blower may be permitted by the administration if it fulfills the requirement stated in above point. That is, capacity must be 1.25 times the cargo pump's capacity, and if required, spare parts has to be also available. A sort of arrangement must be provided in the suction and discharge connection side of the blowers. Generally, the blowers are used for the gas freeing, hence and air inlet with blanking arrangement must be provided at normal operation. Blanking arrangement also is to be secured. Continuation. Cargo tanks are pressure tested at 2500 mm of water gauge and 700 mm of water gauge on the vacuum side. These are the tank testing pressures. The blower pressure must not exceed the testing pressures. Minimum pressure to be maintained by blower is 200 mm water gauge in cargo tanks. Positive pressure always. There must be high temperature alarm at about 65 degrees centigrade and high temperature trip around 75 degrees centigrade to safeguard the blower. The driving media for blower can either steam or electrical power. Both can be utilized. The blower must be located at aft of the cargo tanks and cargo pump room in the ship. Okay, now this is something which is your schematic diagram of an IG plant. This line tells you about the barrier, or you can say the left hand side of this is your non-hazardous area and right hand side is your hazardous area, or you can say this area complete is your deck side and this area complete is in your engine room. So that's why it is non-hazardous and this is the hazardous. Okay, so that all you have to be very careful while you are going or walking on these areas. Okay, now we are going to see the starting point of it. The flue gases from the boiler uptake is coming. This is your flue gas isolating valve, which will isolate the complete IG system from the boiler. Okay, so if it is open, it will allow the IG or the flue gases to go to the scrubber, and here you have the water seal, and through the scrubber, after the demistor, it passes through to the IG blower inlets. These are the inlet valves for the IG blower 1, IG blower 2, and outlet valves for IG blower 1, and this is IG blower 2. Okay, this is your recirculation line back to the scrubber. Okay, this is the pressure regulating valve. We will see in the later slides how this works. Okay, after that it goes to the hazardous area. The vent valve system is the deck water seal. Deck water seal is a natural non-return valve system fitted to that. After that, mechanical non-return valve, and then you have deck isolating valve. So once this valve is closed, the deck is isolated. This is the main purpose of it. And then of course you have the various tanks, and you have the carbo tank isolating valves. These are the carbo tanks in which the isolating valves are there. Okay, and each tanks are having your PV valve and PV breakers also. This is your PV breaker, you can say, and it is going to the main mass riser. So this is something which is the schematic diagram, and or you can say block diagram of the IG system, which I have explained to you in this one, and each component wise description is given. Okay, now the brief working procedure, which I have already explained earlier. So these boiler uptake gases are drawn to the scrubber through the flue gas isolating valve, and in a scrubber these gases are cooled, cleaned and dried before sending to the tanks, and then it is going to the IG blower, and this IG blower take the suction, and then it is passing through, and it is going to the deck seal, and through the deck seal it is going to the deck. That is the main thing. Regulation of the gas quantity delivered to deck is taken care of by the gas control valves, and the deck pressure is also being maintained by the pressure controller. If the deck pressure is lower, then the set point, the output signal will be raised to open the valve more. So that is the principle behind this. Okay, as we have seen the working already, now we are going to see about the components of the inert gas system. So the components which are being utilized for inert gas system. So exhaust gas source, we know that the boiler uptake is the exhaust gas or the flue gases, or in case of IgG is there. Okay, so this is basically the exhaust uptake of the boiler. Inert gas isolating valve, it serves as a supply valve for the from the uptake to the rest of the IG system, and if it is closed, the IG system is isolated from the boiler. Okay, the valve is shut, then the flue gases and the valve are at lower temperature, causing the condensation of H2SO4, because the flue gases are there, and it is there in the valve side and all, and if it is not being used, so the condensation can occur, and the moisture content will be there, which will react with the SOX and form the H2SO4. The dew point is about 110 to 120 degrees centigrade. So at this point you have the dew formation and the formation of H2SO4, which will highly corrosive in nature. So how to prevent it? That to prevent it, there is a continuous supply of air is fed to the inert gas isolating valve, and the sealing and cleaning air is also being fed it, so that there will not be having any H2SO4 formation, or the corrosion is being prevented. Interlock is also between the boiler soot blow valve and isolating valve is there. So if this is open, that will not open. So these are the some factors associated with the inert gas isolating valve. Now the scrubbing tower. Flue gas enters into the scrubber tower from the bottom and passes through the series of water spray. So here we have seen it acts as a seal also, it acts as a cooling part also, because the flue gases which are coming from the boiler, that needs to be cooled, that needs to be cleaned, and when it comes out of the water, then there are water sprays also, that spray is also happening over there, and after that it has to pass through the demister pads, and this is having the zigzag path. Okay, so the baffle plates to cool, clean and moist gases remove the soot and other particulate matters. So these things are being removed. The SO2 level also decreases 90%, and the gas becomes clear of the soot. Has has got water seal to prevent the leakage of the flue gas into the boiler uptake, that is always there, and the plant is not in operation. Material of the scrubbing inside the nickel chromium alloy lined based upon the section coal tar paint is being given inside the scrubber tower to prevent the corrosion and all, or sometimes you have the rubber glass fiber rubber part or the glass fiber epoxy resin also is there. As we have seen already, the demisters. So demisters are basically provided for the removal of the water droplets which can cause the corrosion further if the waters are not being removed. Removal of the water droplets largely depend upon the gas velocity also, that is also one of the factor, and you have the zigzag type of the polypropylene matrices which is being fitted and through which the IG has to pass through, and the water droplets are sticking to this material, and the IG will pass over and these water droplets will fall down. Okay, so impingement type is there and the centrifugal type is there, and both are efficient manner. Direct impingement on the knitted plastic wire mesh is being provided, and centrifugal type it is also here very efficient type of the demister. Demister must be flushed with the fresh water after shutdown. This is very important because otherwise it is corrosive in nature and this material will be inert gas blowers. As we have seen already, the capacity must be at least 125% of the shipped cargo discharge rates. Blowers are of the constant speed machine and capable of maintaining a minimum pressure of approximately 200 mm of water gauge. Blowers are provided with the arrangements of the water washing, and it prevents the imbalancing. Okay, so after use the blowers has to be water washed so that whatever the soots and deposits which will done on the impeller of the blowers, that will be removed. Water washing must be done at least 10 to 15 minutes so that when plant is being shut off, okay, so that it is completely clean and clear of the soots and the imbalancing is not done. High flue gas temperature is also there, that is approximately 65 degrees centigrade. Material of the impeller, as we can see over here, this nickel and aluminum bronze, and casing internal is lined with the rubber or fiberglass. Basically this is to prevent the corrosion part. Boiler, this blower shutdown conditions: flue gas temperature 75, low water pressure to scrubber or low water flow rate to the blower, high water level in the scrubber. These are the conditions in which the shutdown is being done. Okay, now we are going to see about the IG pressure regulating valve. The pressure within the tank varies with the atmospheric condition and the rate of discharge. Basically, we have to control this, and to control this variation and to avoid the overloading of the blower, a pressure regulating valve is attached after the blower discharge, which recirculates the excess gas back to the system, thus maintaining the steady pressure. Basically it recirculates back to the scrubber tower. And sometimes when we are closing or changing over the tanks also, if the valve is not properly handled or not closing and opening sequence is not properly followed, this is being possible. Deck seal. Purpose of the deck seal is to stop the backflow of the gases from the tank into the IG system at the boiler uptake. It is a natural seal in the IG system. There will be a continuous supply of water by two separate pumps. When we talk about a deck seal, a level of water is being maintained by the weir, that is your overflow drain, which causes the excess water to drain overboard. The overflow drain is protected by the U seal. A low level alarm is also being provided for the protection of the deck seal. Heating arrangements are given as the cold weather protection. Okay, and in that one we have the demisters also. Okay. So this is the functionality of deck seal. In detail we are going to see in the diagrams. Okay, in this slide we are going to see about the functionality of the pressure regulating valve. It is basically regulating the pressure. This is your scrubber tower, this is your blower, this is your pressure regulating valve, and this is your recirculating valve which is being fitted. So both are being attached. You can see that pressure controller is attached to both of them. It gives signal to both of them, and pressure transmitter. Suppose in this line we have the rise in the pressure. Okay, so this will be sensed by the pressure transmitter. This gives signal to the pressure controller. What happens? This recirculating valve will open, and whatever the IG gas which is coming over here, this will be recirculated back to the scrubber. Okay, and this pressure controller, this valve will be closed and this valve will be opened. So thus the pressure is being maintained towards this side. Okay, in this slide we are going to see about the pressure vacuum breaker, the PV breaker.
This is only one in the complete IG line. When the PV valves does not work, then the PV breaker will work, and this is definitely work. Okay, because it is based on the water. Okay, and it helps in controlling the over pressurization and under pressurization both. Okay, as the water is there, if the vessel goes to the sub-zero temperature, so water should not freeze. We have the anti-freezing agent, that is ethylene glycol mixed with the water. Okay, and when we talk about the over pressurization limit, this is 1800 mm of water gauge, and under pressurization 400 mm minus 400 mm of water gauge. Okay, so this is the main function of the PV breaker. Okay, we'll see by the diagram also. The oxygen analyzer, this is the thing which is fitted for measuring the oxygen content in the IG. Okay, so generally at the point of generation it should be less than 5%, and more the recirculating valve leads to the gas back to the scrubbing tower. This is to prevent it going to the tanks. Okay, so oxygen analyzer is also a vital equipment, and it is being calibrated also before starting or functioning of the IG.
I hope all of you have understood the functioning of IG system and the components. The major description of the deck seals, different types of deck seals, and the PV valve and PV breaker will be given in the next continuation video. Thank you. Thank you all of you.